Hi, everyone. Welcome back to CI Math 389. Today we will discuss Lesson 5, Systems of Equations. System of equations. When you solve for system equations, sometimes you find the solution is one solution. Sometimes you have a zero solution, no solution. Sometimes you have infinite many solution. And I think that this is, you can easily to find when when you do the graphing. So today I think that I will start with a graph, and you will get a better understanding of system equation, right? And normally when you say one solution, that means we have one line and then meet another line, and we meet one point, and that means one solution, right? So two equations, they meet one point, that was one solution. What about no solution? What happened to no solution? That means I have one equation like this and the other equation like this. So they have a parallel line. So therefore no solution. All right. And then how about how infinite many solution? I have one sixth equation like this. And then I have another equation like this. All right. And then actually they meet only one single line. So therefore it is infinite many solution. Okay. So let's find out some examples. You get better understand. For system equation. Okay, for graphing. Let's say I want to do x plus y equal -3, 2x minus y equal -3, and I want to do the graphing for this. So I want to graph this system equation. Well, first of all, I will find out the table like this. Okay. And then I would graph, like a linear equation, okay? Now remember when we do the linear equation and we make a table like this, right? So therefore, let's say I'm gonna start with this equation, x plus y equal -3, all right? So therefore, I put on the 0. I put on the 0 for this, right? So x is equal 0 plus y equal -3. So how many for y? 5. Y is -3. That's why we put down -3 here. Now what about if x is equal 1? So put on the 1 there, or x plus 1. Put on the 1 there, and what about y equal -3, right? So therefore, y is equal how many, right? -1 minus 1. So that's why we -4, right? Okay. So that's why we have this table, right? So now we have a 0 and 3, -3, 0 and -3 right here, and 1 and -4, 1 and -4 right here. How many points can determine a line? 2 points. 2 points can determine a line. So 2 points can determine a line. So determine a line like this. So that's the 1, okay? And then what about the other equation, 2x minus y equal -3? Let's say I put on 0 for this. So 2 times 0 minus y equal -3, right? So 0 minus y equal -3. How many for y? Y actually is a 3, right? 3. That's why we have a 3, okay? And now 3 for this. And how about we have, if I plug in x is for 1, so 2 times 1 minus y equal -3. How many for y? Okay. Y equal, see 2 minus y equal -3, so y actually is 5, right? So we have a 0, 3, 0, 3 right here. 1 and 5, 1 and 5 right here. And then we can determine a line like this. We can draw the line like this. And then earlier, we already draw this line. All right, so now you can see two equation meet one point is right here. So that is one solution, okay? That is one solution. Let's do another problem. 4x minus 2y equal negative 6. 2x minus y equal negative 3, right? Again, I want to plug in 0 for 4x minus 2y equal negative 6. So plug in this is 0 and minus 2y, and which is equal negative 6, right? And then 0 minus 2y equal negative 6, right? And both divided by negative 2, so therefore y is equal 3, right? That's why we have a y equal 3, okay? And similar for the second one, okay? 4 times 1 minus 2y equal negative 6. And then 4 minus 2y equal negative 6, right? Minus 4 for both. Negative 2y is equal negative 10, right? So divided by negative 2, so that's why we have a 5, right? All right, so now we have a table 0 and 3. Where is the 0 and 3? 0 and 3 right here. What about 1 and 5? 1 and 5 right here. Yes. And then we can just graph this. It's a red line. The next, I want to plug in 2x minus y equal negative 3. All right. So 2x minus y equal negative 3. Let's say I plug in x is equal 0. So x equals 0. So 2 times 0 minus y equal negative 3, right? Negative y equal negative 3. So therefore, y is equal 3, right? So that's why we have 0 and 3. All right. And then next, I want to plug in 1, see what happens. We'll plug in 1 there. So 2 times 1, I'll change different color. 2 times 1 minus y equal negative 3. So how many for y? 2 minus y equal negative 3. Y is equal 5. That's why we have 1 and 5, okay? So now we have 0, 3, again 0, 3, 1 and 5 for another line, right? The second line. And then here we have overlap this line, see? Actually it's overlap, right? So therefore, when we solve for system equation for a problem like this, it's infinitely many solutions, okay? Let's do another problem. 3x minus y equal 1. X plus y equal 3, and want to graph this, right? Again, I plug in 0 there. 3 times 0 minus y equal 1, right? So 0 minus 1, 0 minus y, negative y might equal 1. So y actually is negative 1, right? Times negative 1 times negative 1. So that's why we have 0 and negative 1, okay? Now what about this? The second one, I want to plug in 1. What happened? 3 times 1 minus y equal 1. 3 minus y equal 1, right? So y is equal how many? Y actually is equal 2, right? So now we have this table, 0 and negative 1. So where is the 0 and negative 1? 0 and negative 1 right here. Then 1 and 2, where's 1 and 2? 1 and 2 right here, right? So we can graph the line like this, all right? Similar, we can do the other side, the other equation, this for this, and we make a grid table like this. So if I pick up 0 and then y is equal 3. If I pick up 1 and then y is equal 2. So 0, 3, so where is the 0, 3, 0, 3 right here. 1 and 2, 1 and 2 right here, right? So now we grab the line. Oh, here, we make 1 point there, right? So therefore, we have one solution. We have one solution, okay? Next problem. Grade x plus y equal -3, x plus y equal 3, right? So now if I plug in x is equal 0, 0 plus y equal -3, y equal -3, right? So that's why we have 0 and -3, all right? And then if I plug in 1, what happened? Now 1 plus y equal -3, y equal -4, right? So that's why we have this, right? Similarly, you can do the other table like this, okay? So 0 and -3, whereas the 0 and -3, here is a 0, -3 right here. 1 and -4 right here, right? So we have a graph like this, right? And we can make another table for the second equation like this. This is the second equation, right? So we have a 0 and 1, 0 and 3, 0 and 3 right here. Now 1 and 2, 1 and 2 right here. Oh, look, we can grab like this. See what happened, right? They don't touch, they don't, overlap. So therefore, we have no solution because it is a parallel line. This is a parallel line, okay? All right. Next, system equation. We have how to solve for system equation. We have several different methods we can do. The first one is substitution method, and we can do the addition method or subtraction method, okay? So let's take a look for this example. All right, I want to solve for this, y equal 4x and x plus y equal 5, all right? So I basically just substitute y, all right? So here, y I'll have to substitute as a 4x. So that's why we have x plus 4x is equal 5, right? X plus 4x, how many? Is 5x. So 5x equal 5. So how many for x? X is equal 1, right? So since we know what x is equal 1, we take we plug in 1 for plugging 1 to y. So therefore, we know y equal 4. Okay. So this is a solution. X and y is equal 1 and 4. How many solutions we have? We have one solution for this. Okay. All right. So now this is the first method. All right. Let's do another problem for this. I want to do substitution. X equal -4y for the first equation. The second equation, 3x plus 2y is equal 20. All right, so in here, I want to substitute x equal -4y, right? So here, 3x plus 2y, I will replace x as y, right? How many? X is equal -4y, so that's why we have this, right? And plus 2y equal 20, okay? Now 3 times -4y, how many? Which is -12y, and plus 2y equal 20. -12y plus 2y, how many? -10y, like this. -10y equal 20, y for how many? Y is equal -2, right? So now we figured out y is -2, right? Now, how many for x? We take a -4 times a -2, which is equal 8. That's why how we figured out this. Okay, substitution method. Okay. Now, what about elimination method? So I want to eliminate. Actually, the system equation, we have two variables, right? So now I want to eliminate one variable. So I can do addition or subtraction, right? So in this example, I want to do addition. So let's say I have equation 1, equation 2, right? I want to take equation 1 plus equation 2, right? Then see what happens. All right. Take equation 1 plus equation 2. So this is x plus x, 2x. Negative x plus positive x is equal how many? 0. 1 plus 1, how many? This is 2, right? Now we have 2x. We have a 2x equal 2. X is equal how many? X is equal 1, right? Now, once x is equal 1, we put in equation 1, see what happens. So 1 minus y equal 1. So y is equal how many? Y is equal 0. So we have how many solution? One solution, x of y, which is equal 1 and 0. Okay. Okay. 1 and 0. Okay. So that's do addition. Now, what about if we do subtraction work? Okay, let me try it out. See if we'll do subtraction is work. Okay, x and y equal 1. X plus y equal 1. Equation 1, equation 2, and I want to do subtract. I want to take equation 1 minus equation 2. Okay. Equation 1 minus equation 2. So x minus x, 0. Negative x and negative y minus y, how many? Which is negative 2y. 1 minus 1, how many? 0. Negative 2y equals 0. How many? Y equals 0. Right? Still work, right? Then we know y equals 0. We take it back to equation 1. We can figure out x is equal 1, right? So x is equal 1 and y equals 0. This is our solution. 1 and 0. Okay. So either method is working, you know. Either we want to do addition and subtraction is working. Okay. All right, now next. I think that this is a problem we talked about before on the lesson 1 for problem solving. All right. So we have to do this problem, you know, by using a system equation, right? You can do so many different methods. You can do system equation, you do the graphing, you can do the table, okay? Okay, let's do this problem again, all right? And you can take a closer look, you know, the system equation. A farmer has 18 animals in the farm. 50 legs are visible under the door. How many are chickens and how many are pigs, right? Can we say how many chicken? We say chicken is X, right? And how many Y? Y is pigs. How many pigs, right? So we set up the equation like this, right? Each chicken, how many legs? 2 legs, right? Each pig, how many legs? 4 legs, right? So that's why. And how many legs in total? It's 50, right? So x plus y equal 18, which is 18 animal, right? We have 18 animal and 50 legs, so 50 legs like this. So in this time, I wanna do the substitution. So x plus y equal 18 there. So x actually is equal 18 minus y. So that's why we have 18 minus y, right? So 18 minus y, I want to substitute, and I'm going to put in there as x, right? So 2 times 18 minus y plus 4y equal 450, right? And then next, we do the discrete property, 2 times 18, 36, and minus 2y plus 4y equal 50, there, okay? And then we take negative y, 2y plus 4y, which is 2y, that's why we have 2y here, all right? And then both subtract 36, that's why we have 2y equal 50 minus 36, which is 14, right? And next, we both divided by 2, so y is equal 7. All right, so now we're finding out how many pigs are there. We're finding out 7 pigs. And how many for chicken? We have 11 chicken, right? So once we got the answer, we have to double check if it is true, okay? See, the total animal is 18, so 11 plus 7 is 18, makes sense, okay? So this problem, look, we will use a system equation to solve, okay? All right, so we are here for today. If you have any question, feel free to send me an email. Thanks for watching, and you have a great day.